So, we're here to talk about a couple things. The first thing is safety. I just want to get a safety point across. So this is our entire gas system at a smaller scale, of course. 90% of the visuals that you see are based underground. So about 10% of this is all based above ground. So we'll go through the demonstrations, but before I get started, I want to introduce my team. First, I want to start from the top. Mr. Brian Clark is back there. That's my director from gas delivery. My name is Jimmy Orm. I'm the manager of gas construction and maintenance up in the northern sector of Delaware. Basically from the Christiana Bridge all the way up is our sector. From the Maryland border to the PA border to the river. With me I have Joe Rollo. He's one of my senior lead mechanics in construction and maintenance. Mark Piazza is a gas energy utility man, and Anthony Lewicki is one of my gas construction maintenance operators. So with that, the importance to us is when we see something, we say something. 811 is our biggest deal underground. Anytime we're digging, we're going to get a hold of Miss Utility. And with that, we expect all the contractors and all the utilities to kind of be a part of that family, because we have utilities underground everywhere, all over Delaware, Maryland, the 5 states, Virginia, Washington, D.C. So we have underground utilities everywhere. Some are at medium pressures, some are at low pressures, and some are at elevated high pressures. We'll talk about the differences when we go through the demonstration and kind of let everybody know what we're dealing with in the gas business here. And this is set aside from electric. So I know when people talk about DelMarVa, they think right away electric. DelMarVa has a big piece of the puzzle in the gas delivery business also. So with that, I'm just gonna, like I said, I'm gonna stay away from this screen. Well, I'm gonna talk about what we have and go through this in detail, not to bore you. We're gonna try and hit every little thing, and then afterwards we'll let you kind of take a stroll around the display here and kind of do some hands-on and look and see what we have. Okay, so Joe, I'm going to turn it over to you, buddy.
So like Jim said, the trailer is showing you our gas system when we buy the gas from outside the state, and it comes into a regulator station. A regulator station is basically like an electric substation. Takes the pressure from, we usually get it 170 psi up to 500 psi, and it runs through the regulator station and drops it down to 38 psi, which is the operating pressure for a normal residential area, and it just flows through basically all the way through the mains until you get to a service. Everything now is plastic. There's a lot of steel in the ground. There's a lot of cast iron. The wire goes with the service so that we can trace it out. We can find where everything is. Without the wire being plastic, you have no idea. We do have some plastic in the ground that didn't have wire, so that makes it kind of difficult to find where it is. The cast iron in the system, we're slowly getting rid of. We're at a point where I think we're like 5 years away from getting rid of all that. Some of that stuff is from like 1864. 1900, 1920, and it's primarily our low pressure, which is like half a pound. It's not the most reliable system, so we've slowly tried to get rid of that. Everything's kind of going more towards the high pressure. As far as above ground, normally this will be above ground, the regulator in the regulator station, and then the meter that you guys probably would be used to seeing and deal with the most. As far as everything else here, we have some demonstrations where we can demonstrate a low pressure versus high pressure. So this is the regulator that we use to drop it from 38 pounds to half a pound for residential use in a house. So you can see the difference between how much pressure comes out the end with it regulated versus if it was just straight 38 pounds. And we have another demonstration over here where called an excess flow valve. It's kind of like a safety check valve. So if somebody hits the line past that, it senses all that pressure and it trips so that it won't just keep blowing. It'll pass a little bit so that you know that there's a leak, because we've had people that have trenched through the line, didn't know they hit it, but they smell a little bit of gas, or they didn't hear it when it first popped. So it'll pass a little bit so you can smell it. Kind of like just an extra safety feature that we probably started using about 10 years ago, and it goes on all services, unless it's a large commercial service, because sometimes it'll trip those out just by running in general. So we have that. We also have a burn stack. So if we have miles of pipe that we're retiring, say it's 12-inch and we have to retire 2 miles of pipe, all that gas that's inside of that pipe, we don't just let into the atmosphere. So we burn it through the stack. It's the safest way to do it. So we have that as well.
So if you look at the picture up there on the screen, that's pretty much what it looks like when we burn off gas in the free air. So what that accomplishes is we're basically burning off the residual gas in the pipe, and then we're trying not to leave. We're trying to go down to zero balance in the pipeline so that we can safely work on it. And this is the way we're transitioning right now to different concepts where we have a machine called the ZVAC machine, where we can take a machine, dump it in one, or take it out of one pipe, dump it in the other transmission line or distribution line, however, whatever pressures we're at, and we eliminate both burning off and any carbon seal or anything going into the free air or that contaminate, whatever environmental aspects. So that's what that does.
And then last we have, so that would simulate a piece of main with a 3/4 inch steel T going to a house, and if there's a leak on it, so they have pinholes. Those metal parts are clamps that we put on them to stop the leak. We have that simulation where you're going out for a gas leak, and it has a hole because it's deteriorated, what it would be like with that. Anything else?
Okay, so I just want to throw a scenario at you. Just last Friday, we called a Friday special at 2 o'clock in the afternoon when everybody's ready to take off. We had a contractor come in, put his bucket into an 8-inch gas main. Right here is only a 4-inch gas main. So now you can absolutely see the difference in the size. We only run at 35 pounds in the North District of DelMarVa. However, our sister companies, BG&E down in Baltimore, they run at 99 distribution pressure. So the amount of gas that's flowing out of there when something's damaged is so significant. It alerts everybody that there's something going on and something pretty bad. So you're going to get all the other emergency services responding, the police, the fire, the emergency response out of the state or county, and it becomes a big deal. So anyway, backing up, not to make a long story short, but that Friday we would have had to close 7 valves and lose a subdivision of about 80 houses, commercial combination. We try to avoid that at all costs, but sometimes we just can't. We were lucky to get in there and get on both sides safely, dig up other holes, and we have what's called squeezers. We can actually squeeze this plastic pipe. So we have special tooling that we can squeeze, isolate that segment of workspace, and then cut out whatever is damaged. So that's why I keep falling back on Miss Utility and all that to dig safe, because every time we have a leak or we have a damaged radar goes up, it takes a lot of assets to move out there and fix the problem. So with that, we'll go through the different scenarios here. Like Joe said, this is an excess flow valve. So if you have a service coming into your house, once the service comes into your house, we're going to stick this off what's called a T at the main. So we're going to tap the main, we're going to run a service, the crews are going to run a service. We're going to put that excess flow valve in it, because if that service is hit by accident, a lot of homeowners go out, plant flowers and plants, and nobody bothers calling. So you got your post hole digger, you're digging down, and you hit the plastic line. It doesn't take much. 1/2-inch plastic line will snap in an instant if you put enough pressure on it with a post hole digger and a sharp blade. What this does is it'll kick in. It's just like a check valve.
So usually this flow valve is here at the end of the T, like you said. When you hit it, you would hear that whoosh. This trips, stops the gas. Then when it's fixed, once the pressure builds back up, you'll hear this. This will re-click, and then you have gas pressure again. I don't know if you can hear it over the compressor.
So it'll equalize and reset itself. So we can just go in. So we kind of know when we pull up a service card in the office, we know that that valve is in place because the guys put it in 10 years ago. We have service records that show all that. That let us know, okay, it's broken, it's damaged, but it's more safe than it would be if we didn't have this flow valve because it would be ripping out of that piece of plastic. Moving on to the next thing. This is the valves I talked about. We just had this cut open. By the way, I think it took us, how long did it take us to build this, Joe? About a year?
Yeah.
So it took us about a year to put this trailer together. We have an engineer back at the shop, Laszlo, we call him Laz. He took pieces and parts from each division in our company, and they went ahead and built this nice little display so everybody can get an idea what we do. So this is just a valve, a cutout of the valve. It's an actual full port valve. So, you know, our guys know that to read the operators, they know what direction it is, just clockwise closed, counterclockwise open. And that's the valve I talked about that we would have had to close 7 of them if we had an isolated area. And they're not as pretty as that on the ground, I can tell you that much. Most of them are slop. We have to sometimes blow them out, dig them up, and that's like the valve box behind it. That's what you see probably at your residence somewhere with the lid on it next to the water box somewhere. Okay? All right. Want to talk about anything else over here?
So the display for the pressure, like I said, this is the regulator that you would have on any residential, sometimes commercial, depending on the size. So you can see the difference between, right now, the pressure running through here is 1/2 pound. So you kind of see how slow it is. On the other end, this is where you just have the full 38. It's substantially different, especially if you go to a hit line. That's kind of what it's going to sound a little bit like that. Usually it's a lot louder.
Now
So,
the little one might work better for kind of what it would sound like blowing.
yeah. So it's kind of, we also have ones that go up to 2 pounds of pressure depending on what the customer needs. Sometimes commercial, they need more like 2 pound system versus just the 1/2 pound. But the most common one is this. Unless you're already on the low pressure system, then you don't have to have anything like this. So the other one would be,
Yeah. So we talked about, you know, when we're isolating, we're working on a segment. It's a planned shutdown. So we're either doing a reinforcement, a replacement of old main, or we're cutting out larger type valves on a transmission system, which our transmission system runs between minimum 180 that will run transmission coming in. We call it over high pressure because actually transmission will run at 350 pounds usually. So we run around 180 in the DelMarVa Peninsula, the DelMarVa region. So once we do that, and we have bigger, what's called Bueller equipment that we're able to cut into the steel, and then we're able to stop it off with big, what we call wedge stoppers. They're pretty monstrous and they're pretty heavy. So we'll drop all that equipment into the shoring or the pit, and then we'll go ahead and stop off, and we're able to isolate our work area. Sometimes we have a run that we're getting rid of because we replaced 3,000 feet up to a mile of main, and we don't have that opportunity to stop off both sections. So we're going to stop off one, we're going to tie in the new stuff, and then we're going to bleed it down. And this is how we bleed it down. We put a perch stack on the very end of the run, usually somewhere around a regulator station or just outside of a regulator station. So go ahead and show them how this works. So this represents This represents residual gas coming first. We're trying to pack the line because we're bringing actual natural gas. We wanted to get to at least 99% natural gas. So we're packing the line, we're pushing it, and over a mile long takes a little while, probably about 3-4 hours, because we're opening the valves very slow and we're just introducing gas into the system. So if you, this kind of represents, again, that picture that I had on the screen. Yep, it's on the screen, and the flames get pretty big because once we get to a higher pressure, we're going to open the valve fully open, and then this is kind of what it represents. At night it's pretty cool to see because it lights up the area. But it's our safe way to make sure that we have no oxygen or air in the system. We want to get all the air in the system, because if air gets into your house up through the regulator and the meter, it's going to knock out your pilots, and you're going to smell that gas coming in from the street. You're not going to know where it's coming from, and that's why we get the calls. Okay, so that kind of gives you a snapshot of what it looks like, what our systems look like. This is basically our intermediate system. Like I said, our higher elevated pressure systems are all steel. I don't believe we have too much plastic that are in high demand over our 35-pound threshold. So basically our operating pressures up north are hover around 35 pounds. We do have 200-pound systems. We have some 450-pound systems coming across from the river. And we do have a lot of large diameter equipment and material that we work with. Other than plastic, we also work with a lot of steel and a lot of cast iron. So like Joe said, there was a lot of cast iron in the ground from the 1800s, early 1900s, and it's still in the ground, and we are in the process of getting rid of it with trying to get 8 miles of main a year, take that out of the ground and replace that with brand new polyurethane, so that we can get the system back up and running with minimal leak calls, odor calls, leak calls, and response calls, so we reduce that amount of problems in areas. So right now we're kind of concentrating on the Wilmington area and the surrounding subdivisions, and then later on we'll be branching out and starting to tackle some of the steel that we have in the ground that's a little bit older that we want to get rid of and replace that too with newer equipment. Okay? Any questions?
I got one.
Sure.
If Joe Hogarth in the back over the front yard, put a gas line, can he trace that, the tracer wires?
Yeah, you want to talk about the tracer wire, Joe?
What's the standard for repairing the tracer wire? You just find it, wrap it together.
We just get what they call a bug. Any kind of electrical bug looks just like that.
Yeah.
We just bug it back together and then tape it. So if we break it or homeowner breaks it, you don't want to like twist it with like a twist knot or anything like that. Yeah. Well, when we do it, we try to do it the proper way with the bug. I mean, there's people that have actually twisted them together and taped them before. That will work. It doesn't hold up long term, but it will work if you break that. But normally we can actually tell where the break is too. So if you broke it and didn't know, if we go tracing it and it stops right there, we know you broke it. Or someone broke it, or they ran out and that's as far as it went. We can kind of trace it as far as right where it's broken or right where it ends. So sometimes, depending on installation, that could be, we can figure it out, just like, okay, you're 2 feet away from, say, the meter, or you're out in the street and now you're not getting it, and you lost it, you don't know where the main is. So it can kind of go both ways. But if you at least try to twist it back together, that would be helpful. But normally we can figure it out.
So the hook-around tracer, is that thing on the electrical signal, or is it something on the wire?
It's just a wire, and then we have a it's called a Metrotech. We clip onto it, and it'll trace it out the whole way, the whole length. So it's almost like kind of like a minesweeper, like if you were going out in the sand trying to look for coins or something. It's kind of similar to that. and it'll actually tell us exactly where it is. So if I go too far to the right, it'll actually tell me I need to go back farther to the left. So it'll tell me exactly where it is, and then it gives us a reading. If you're anywhere in the high 600s, 700s, you're right on that wire. So with the technology now, even if you break it, we can kind of tell that it's broken or whatever. Yeah.
Yeah, so we don't have any equipment that can pick up plastic. I mean, there's just nothing out there. So that's the reason we run the tracer wire on everything. And you'll see the balls too, the yellow balls in different locations. Those are called ball markers. We have a special piece of equipment that'll actually detect those ball markers, and we usually drop those near critical spots, either on a fitting that we're joining pipe together, or a valve that's critical to us that we lose the box from. Just different types of things that we'll put those on.
Now, kind of going to your question, the transmission lines that we have, we actually induce a voltage onto those for corrosion debris. So we induce a voltage on there to stop the corrosion and all the pipe breaking down. So we do that on the higher pressure stuff, the steel lines. It's called a
Hanover.
no, for the transmission.
Oh, the rectifier.
The rectifier. Yeah, so we actually induce voltage onto those lines to help with corrosion. So that's a little helpful.
I thought the wires are tied together for the roads. And where you tie back together, you pick it up after that.
Yeah. Normally, even if it's corroded, it'll still pick it back up. The only other thing we didn't really talk about that I think is probably important, if you guys didn't see, this gooseneck here, the yellow gooseneck. A lot of people don't know what that is. You'll see those at major road crossings, or sometimes you'll see them in the middle of nowhere. That just means that the pipe we have is going through another piece of pipe as a casing to protect it to go underneath the road or to go someplace it's really rocky. So if you see a gooseneck like that, there's a gas main somewhere around where you're at that's inserted into another piece of main as like a sleeve to protect it. And that's just, if that ever leaks, it'll leak out that gooseneck, so we can tell, okay, there's leaking somewhere around there. So if you, for a visual, if you ever see that gooseneck somewhere in the middle of a field or a road, there's a gas main there. Sometimes we don't bring that up enough to people to tell them what that actually is.
A vent for the case.
Yeah, basically a vent for the, it's exactly what it is. And then we inspect those, I think yearly, someone goes around and inspects them to make sure there's no leaks anywhere on them. So basically just.
Any other questions?
Got a